Good afternoon. This is Jyoti Singh from EB10 and the topic which I have chosen for algorithm is quicksort algorithm. So first of all, I would like to tell what is quicksort algorithm and then I will be explaining it with an example. Quicksort algorithm. Quicksort algorithm is a sorting algorithm which is most commonly used in computer science. It depends upon divide and conquer rule. Like we partition the array into two sub-arrays, that is to the left side array and right side array, depending upon the value of the pivot element. Now what is pivot element? Pivot element is basically the element from the array which we are choosing. It may be the middle element, it may be the greatest value, it may be the least value, or it may be the last value. Depends upon the user. We choose one element, we call it pivot element, and then if the other elements are less than the pivot element, we'll keep it to the left side, and if the other element, if the few elements which are more than the pivot element, we'll be placing to the right side. This is how we recursively sort the sub arrays, and then we'll finalize our final sorted array.
Topic for algorithm is quicksort. Quicksort is highly efficient sorting algorithm as it is based on partitioning of array of data into smaller arrays. Quicksort partitions an array and then calls it recursively, repeatedly twice or maybe more than two, to sort the two resulting arrays, which is to the left and which is to the right. As we know, it is also known as divide and conquer because it divides the array into two halves, one to the left side and one to the right side depending on the pivot element. Now we get a question, what is pivot element? Pivot element is basically an element which is to be chosen from the given array, and based on that element we divide and select what to be kept on the left side and what to be kept on the right side. Basically, on the left side of the pivot element contains all the elements that are less than the respective, like the given pivot element. Now on the right side it contains all the elements which are greater than the pivot element. As we know, it was discovered by Tony Hoare and in the year 1959, and it was published in the year 1961. Now complexity. Quicksort has worst complexity case, best complexity case and average complexity case. So first we'll start with worst case. Worst case, what is worst case and when it occurs? Worst case is when the partition method most of the time picks the greatest, or we can say that the smallest element as the pivot element, then worst case occurs. The worst case complexity for quicksort is O(n) square. Now best case. When this best case occurs? It occurs when the partition of the process not only most of the time but also always, it always picks up the middle element as pivot element, and because of which the best case occurs. Now the best case for time complexity for pivot quicksort is O(n) log n. Now average case. Average case is the time complexity for quicksort is O(n) log n. Now we'll start with an example on quicksort. We have given an array A with elements 10, 5, 3, 18, 45, 35, 17, 19, 47 and 38. Now what we have to do, first we have to convert this given data into array form. We have converted A equals to 10, 15, 3, 8, 45, 35, 17, 19, 47, 38. Now what we'll do after this, we'll pick 38 and we'll choose it as the last element, and we'll choose the now we have to choose the pivot element. For choosing the pivot element, we'll be taking the last element, that is 38. Now we have chosen a pivot element. Now the time comes for selection. Now this pivot element 38, we'll check out the left side value and right side value. As we have seen earlier, the left side value is the values which are less than the pivot element, and right side values are the values which are greater than the pivot element. So the values which are to the left side and is less than 38, we'll keep it here. So let's see what elements are less than 38. 10, yeah, 10 is less than 38, 15 is less than 38, 3 is less than 38, 18 is less than 38, 45 is greater than 38, so we'll keep it to the left side. 35 is less than 38, so we'll keep it to the left side. 17 is less than 38, so we'll keep it to the left side. 19 is less than 38, so we'll keep it to the left side. 47 is greater than 38, so we'll keep it to the right side. As we have seen, 45 and 47 is greater than 38, so we are keeping it to the right side, as this depends on the pivot element. Now we'll further take this selected sub array, and then we'll choose a pivot element, and then further we'll divide and conquer. This is why quicksort is known as divide and conquer, because basically it is based on divide and conquer tool. So now the sub array which we have got in the left side, we'll choose here. First we'll choose the pivot element. The same thing we are doing, we'll choose the last element as the pivot, that is 19. After choosing 19, we'll make a selection, which is the elements which are greater than 19, we'll keep it to the right side. Elements which are less than 19, we'll keep it to the left side. And then again we'll choose the pivot element. Now choosing the elements which are less than 19. 10 is less than 19, 15 is less than 19, 3 is less than 19, 18 is less than 19, 35 is greater than 19, so here we are keeping it to the right side. 17 is less than 19, we are keeping it to the left side, and 19 is our main element, that is pivot element. Now we got this C sub array. C sub array means we have 2 times we have divided. Now this is the 3rd time we are dividing. So in this we can see we have elements 10, 15, 3, 18 and 17. Now what we are going to do, we are going to do the same thing. We'll choose the last element as the pivot element, that is 17. Now choosing 17 as the pivot element, and then further dividing into categories of left and right. Right, we have chosen 18 because in this given element we can see 18 is the only element which is greater than 17, and rest all the elements are less than 17, that is 10, 15 and 3. These 3 are less than 17. So we have kept the less value to the left and greater value to the right. Now we have the D sub array. This is just for notification, guys, so that it will be easier for us to divide. Now we'll take 3 as the pivot element, and on the basis of it we'll divide to the left and right. But we can see here we have 3 elements, and 3 is a pivot element, and 10 and 15, these both elements are greater than the pivot element. So these both elements will come to the right side. Now to write it in order, first we have to choose the left, then root, and then right element. Like after dividing these and getting the sufficient end array, since if we would have got here some values, then we would have written left value, pivot element, this is what the root value, then the right value, and then again we'll go on the top, like we are going from down to from bottom to up, and then we'll write the left where we have already done. So we'll write the right, pivot and right, then we go again up, then we'll write the root value and the right value. Like this way we form our sorted array. So let's start. Now see, in this, since we don't have any left value, so we'll take the pivot element, that is 3. This is also called the root element because the division is based on this element, so it will be our root element. Now we have to write 10 and 15 as it is to the right side, because since we don't have left element, so we are writing root 3 and then write 10 and 10. Now we'll go on the top. These three we have taken already, sorted. Now we have to write the root element, that is 17, and then we have to write the greater element 18. Now we'll go further to the C part. Here we'll take the root element 17. We have taken this element, this is already sorted. Then we'll take the root element 19 and the element to the right side, that is 35. Now we'll go further on the top, that is a final, and we'll see that here we have taken as root element as 38, so we'll write 38 here, and then to the right side we can see it is 45 and 47, so we'll write 45 and 47 here. So guys, this is a sorted array which we have formed by using divide and conquer rule, which is popularly known as quicksort. Now the points which we have to note in quicksort is, like I can just give you key notes for quicksort. Quicksort is used for sorting the given array. The space complexity of quicksort algorithm is O(n) log n. The time complexity of quicksort algorithm is O(n) log n. And the most efficient way, that is the implementation of quicksort algorithm, is still not a stable sorting algorithm, stating that the relative ordering of the equal sorted item is not preserved. Because of its functionality, quicksort algorithm is also known as divide and conquer algorithm, as we can see here, as it works on selecting pivot element, that is the root element, and then partitioning the other elements to the left and right side depending on the greater and lesser values.